Hello. Let's get started in a couple minutes. Gonna get some terminals open, gonna get my VS Code cleaned up, and we can get started building. All right, let's start screen sharing. We're gonna go entire screen. And jump on in. All right, my terminal is here. Got VS Code. Ooh, way too big there. And let's get going. All right, so first off today, we're going to look at a couple different programs and try to build them and package them up into Wolfie packages and images. Did a little prep to see what we're going to build. And we're going to get started with some AI stuff. So we're going to get started with the Chroma vector database. And it looks like the Chroma vector database, if you're here, it's one of the more popular ones. It's got 8,000 GitHub stars. And there's a bunch of different releases for it. This is an interesting vector database because it's actually just written in Python and it's a Python library, but you can package it up into a Docker image. And doing so lets you basically run it in client server mode. So you can use it from a different programming language, say, other than Python. So the typical way is to import it in Python, or you can run it behind this web server. So we're going to do the web server version. And I'm going to go through exactly what this looks like and what we look at when we're going to try to build something like this. So in here, we can see that there's a Docker file. And this is the typical one that gets it up and going. So it starts with Python, runs some pip install stuff to get all the dependencies installed, and then starts it up with a Docker entry point script here. There is some native code in here that gets compiled. So we can see that there's some stuff here, and that's why they use a multi-stage build. So let's see if we can actually find this Docker image on Docker Hub first and do some scans on it before we get going. Chroma. Let's see it here. Maybe we can find it from here. There's a compose YAML. Oh, but this still builds it itself. I don't actually know if they publish this Docker image or not. Let's grab this, build it ourselves, and scan it and see what the vulnerabilities look like. And once this gets going, we're going to learn the joys of Python packaging. All right, almost done fetching with Git. Here we go. Let's look at the Docker file. All right. While this build runs and downloads, this could be kind of slow. So we're going to pop open another terminal and get started trying to package this up into a Wolfie. Make this one big too. All right, what I normally do here is start up a Wolfie container image with a shell and play around in there and then translate it to Melange. Wolfie base is just the default Wolfie image with a shell and a package manager and all of that fun stuff. So we're going to get some stuff installed. Let's get Python 3, we'll get pip, we'll get our compiler stuff because we know we need that, and git to clone the repo. All right, Docker is still running there. When this finishes, we'll just do a vulnerability scan. Let's get this repo name again. All right, that finished. Cool. Start cloning and then go back over there and do that scan. All right, we called it Chroma. Let's run this through gripe. Multitasking. Oh wow, that's a lot. All right, we got Chroma up and running, and there are a lot of vulnerabilities, 325. Let's see how low we can get this in our version once we get this built. All right, so we have Chroma. There's about 175 zillion ways to package Python apps. But the way there, and we have a couple ways to do it inside of Wolfie as well. Because this is a full application, what we're going to do is just package this up using pip. We can also go through and package this up as a library and then also package up every single dependent sublibrary in here, get those added directly to Wolfie, which we do as well. But normally for a full standalone app like this that we're trying to package up, we'll do it the first way, where we let pip manage those dependencies for us. So we're going to get started here with, let's find the command from something else in here. Pip3 install dot, yeah, so usually do something like this. We'll see if this works. Let's make a temporary destination. And what is it? -- root equals foo. So this is gonna do an installation of all the dependencies for us, building stuff, and throw it into that /foo directory so we can take a look at the full root fs. Make sure it's something we can package up later with melange. Let's see if this works. We're installing a bunch of stuff here. We're gonna have some compilation happening. Oh, error. All right, so this is trying to build another Chroma library, and it's trying to include some Python headers. All right, so I think this is because we didn't install the Python headers. So we installed Python 3, but we need the headers too, which come in the dev package. Let's try that again. All right, this looks good. We go a little farther. We're building the wheel. Cool. All right, that looks like we're almost done. So we're going to come back here. In that Docker image, the very last script runs Docker entry point. Sometimes these entry point scripts can do a lot of magic. So let's open that up and see what it does. Bin Docker entry point. Sometimes these will call out to other programs or something. So we have to make sure that all of that stuff is installed here in the beginning. And, ooh, this is kind of interesting. So you see that in the Docker entry point, which runs when the container starts up, it's actually reinstalling a dependency. It says they're doing that to ensure compatibility, and I'm guessing that's because sometimes the version compiled on PyPI doesn't necessarily match or is optimized for the operating system that we're going to be installing it on, like let's say ARM versus AMD64, but that's not a very good idea for startup time inside of a Docker image, because this is going to run every single time the Docker image gets scheduled. If you run it 1,000 times in a Kubernetes cluster, you're going to run pip install 1,000 times. And then also that could be a different version every single time. So this isn't really deterministic or safe or performant. The rest of this seems pretty straightforward though. We got an environment variable, and then we're running UVcorn, which looks like a gateway server or something that then calls the Python application and serves. So this part looks pretty straightforward. It uses bash. We're not going to bother with that part. This looks like it could just run with sh. All right, overall pretty straightforward. Cool, this build finished. Let's go to /foo. All right, if we go to bin, we should see the UVcorn thing. Yep, cool. So that we should just be able to call. Awesome. And this is just because my Python path is set up weirdly because I'm in this foo directory. All right, let's try converting this over to melange now. I'm going to open up a new file, and let's take one of these other Python ones that looks pretty similar. So we're going to do something pretty similar to this one. Let's take GG Shield. Let's call it PyChroma. Let's get the right version information out of here. The AI native, and it's version 0.4.7. It is Apache licensed. We've got these things. I don't think we need that. We need Python 3 dev. Let's call this Chroma core. There is no V at the beginning, so we can drop that part. We'll get the commit. I do that. This line here removes a bunch of PYC files, which take up a ton of space, so we normally throw that into our Python packages that we build. Change this part to be, this is our auto update system. So that way when there are new versions of this, we'll automatically pick them up. And let's try to build it. That's probably supposed to match here. Cool. All right. Then we'll build an image and try to run this. All right, I'm going to get my super long and scary. Let's actually go back over here. Get my super long and scary melange configuration to do this build. Where's this part? Cool. All right, let's go. A lot of those flags are unnecessary. Some of them are to help speed up local performance with caching and mounting directories into Docker, the way I happen to run the melange tool myself. While it's running, I can explain some more of this YAML. So this up here is kind of the metadata for the package. The AI native open source embedded database description. We track all the license information to make sure that we don't accidentally package non-FOSS stuff. This means that at runtime, the Python package can't run without Python 3. We can automatically detect a lot of those runtime dependencies, but for interpreted languages, we can't always do that. So we specify that part here ourselves. These are the environmental dependencies for the build system. So these are everything we need to build the application itself. These are the same things that I installed in that container when I ran it. Down here, this is where we get the checkout information. So we pin to the right commit. We know which tag to grab. And then here's the actual installation system itself. So this runs pip install. This throws it into this root directory like I did before. So this is what becomes the final APK package. So I can show what that looks like, assuming the build works. And then this down here just does a cleanup of all of the precompiled PYC files that we don't need for actual runtime. Let's see if it worked. Awesome, it finished. So we can see everything it found in here. These are a bunch of commands that were present in that bin directory. So we can see the unicorn thing. That means this package will provide those as well as all of these other commands. I don't know that we actually need all of these. And so we can do something if we want to be extra safe, like delete all of the ones that we don't need from the bin directory. But we'll skip that part for now. There's also these SO files that are grabbed by the application. So yeah, let's actually add that no provide section just to be extra sure, because this is a full application. We really don't want this to get mixed up in the dependency manager for providing any of these other things. You can see that we do this sometimes for other programs. We want to make sure the right version gets resolved. Let's drop that in here. Cool. All right. Then we can see what else is in here. Let's look at the package itself. So we can look at the tarball. We see a ton of stuff in here. These are all the Python files. See, there's no PYCs, which is good. Those just take up extra space. We've got some shared libraries because we did compile those for our platform. Licenses, all the dependencies. So this thing should just start right up. Let's do a build of it now into an actual image. So we're going to do PyChroma. This says which architecture. This is just a scratch version of an AppCo YAML that I use for debugging and making sure that things work before I actually go ahead and submit the PRs. So we're going to build that here locally using AppCo into an image. Once this comes up, we're actually going to try to start the app. If that works, we can actually go ahead and submit this and then build an image definition off of it too. was going to scan it, but I'll scan it after we make sure it runs, just so it's a fair comparison. So we're in here now. What was the entry point script? Here we go. All right, UV corn, and then all of these things. Let's make, what directory do we end up in? Because it looks like this is going to write some, look at a logging config or something. Where is that? All right, so there's just one here at the root of the app. So we might want to copy this part into the app too as a sample logging config. So we can tweak the launch to grab this part too. Let's try copying it and leave off that log config part. Hey, it works. All right, we got it up. Let's make one more tweak here. Where does Docker set up the, what directory do we start in? Workdir/Chroma. So we're not going to use that as our working directory because that's kind of not standard. But let's make a different one. A lot of different step here. We'll do something like that. And then we'll drop that in here. We'll throw some quotes around this too, just to match. Cool. All right, so then we'll have the logging config in here, and then we will run that same command again with this as the working directory. So let's build it one more time. Assuming this works, we can clean that up, go ahead and submit a PR to Wolfie. Oh, we have to look at the vulnerability scan too. That's going to be exciting. The other one had, what, 237? 235, I think. All right, we're compiling that native library again. That's the one that took a while last time. Awesome. Now let's do the appco build. We'll load it. Now let's scan it because we're pretty sure it works. Magic. 0 vulnerabilities found. So we found 101 packages, 0 vulnerabilities. Let's compare that to the other image one last time. And tons. And you can see that most of these are in things that don't even matter and shouldn't be in the application itself. Like, you shouldn't need Perl to run a Python app. There's some CVEs here in Python itself, and these are missing from ours because we've actually patched these in our version of Python. Lots of other CVEs, stuff in OpenSSL. Some of these are marked as won't fix. Some of them are still pending. And we could pull up each one of these and kind of show the patches that we've applied in Wolfie. Actually, let's do that for one of these OpenSSL CVEs while we're here, just to show how this all works. Let's take, say, this one. I don't know what it is, but let's open it up in Wolfie. All right, so that CVE here, I'll make this a little bit bigger. This is our advisory database inside of GitHub for all of our Wolfie packages. We can see that this CVE was fixed in 3.1.1 R2 of our OpenSSL build. Let's see what that actually is. So yeah, this is a bug in a specific encryption algorithm in OpenSSL. So it's scored as medium. This is still showing up in that other image, but we patched that ourselves in the OpenSSL build for Wolfie. So you can kind of go through and look up each one of those to see exactly how we did this for most of these CVs, but there's too many here to really be worth going through one at a time. There's also stuff like the compiler being left around in here. You can see that. I'm not sure why it's in here, given it's a multi-stage build. But yeah, we see compiler stuff in here, which is clogging this up and making the space bigger. Let's see how big it actually is. That one that we just built ourselves. Yeah, so 675 megabytes. And then we called ours test, I think. Here is this one. So 194 megabytes instead of 675. So that's a pretty significant drop. So it's about the third the size, 0 CVEs, and everything is up to date. Let's head on over and build an image based on this now. We've never actually gotten that far in one of these sessions. So this is a different repository. I'll do a quick reset. Let's just pull and push. Get everything set up and ready to go. All right, so what this is going to do is take that AppCo configuration that we had before and get this ready with some documentation and everything into a state that it can be picked up and used by the Chaincurd images build system that we use. I'll show what that repository looks like over here. Every one of these files in here is an image. And so let's take, for example, let's say the FFmpeg image. There's a basic directory structure in here. Right? There's documentation showing how to pull it, how to run it. There are some tests in here. The tests for this one actually convert a file just to show that it all works. Do some movie manipulation in here. Then there's the configuration for the image itself. That's in here showing the groups, what to run things as, what the entry point should actually be for the image. And then that's about it. There's some other documentation here, some other configuration here explaining how to tag things. Then it all gets stitched together with Terraform at the end of the day. So the Terraform configuration that we have here, we have some at the root of the repository, which lists all of the different images to build. And then we also have some inside of each image here to show how to actually build it, and tag it, and then do the tests, if you run those tests against the image. So let's go ahead and create one of these except for our image, the one that we just made. So we're in here. I like to use this awesome startup script to help get some of these created called copy, and then a little bit of paste we're going to do. So last time I did this, I used the Cedar configuration as a default. Let's use that one again, and let's call it Chroma. Cool. Now we've got that set up. Let's fire up our trusty VS Code. Clear out a lot of this stuff. Let's find the Chroma directory. Cool. And now let's replace Cedar with, let's find all the Cedar mentions and start replacing them because we just did a big fancy copy paste. Chroma, let's hit save, come on over to here. Chroma, the image contains the, just write some actual documentation here. Yeah, that looks right. Maybe we're using the Chroma vector database right now during the autocomplete. But yeah, it did look like it ran at that port. Open it up. What did we do? Uvicorn. Grab one more time and actually test this out because we're going to need to know how it works to write these tests too in a second. Oh, 8,000 was the default, not 8080. Let's fix that. And let's throw an and there so it just runs in the background. Cool. Do we have curl? All right. All right, we got a 404 there. There must be an API that we can hit. Any documentation? I thought I saw some docs here earlier for the API. We can find it in a minute though. Is there a test binary in here? Maybe. That uses Docker. What are the API endpoints for Chroma? All right, here we go. It's all using a Python API. Let's just try guessing. Nothing. Give this another minute. Okay, here we go. Client server mode. All right, well, this is only the Python client. I'm sure there's some way to figure it out. There's authorization, maybe version. Maybe it's under here. Just there we go. We guessed enough and we figured it out. All right, API v1. That got us an actual response. Cool. This is something we can work with to make sure that the server is up and running. All right. API v1 it is. We got a 200. Okay, let's put that in as our test. 8,000. Let's fix this up. Let's fix that part. Let's do a -D. All right. And that should return something like this guy. So we're writing up some documentation. Here we go. Cool. All right. Basic usage stuff. Come in here. Let's set it to Chroma, the package that we built. And this is where we drop in that UV-corn config. There we go. Let's try writing a quick test. So there's not really a help there because all UV-corn does is run that thing. So we can drop this one. Let's change this to all right. So in here we just get to write some fun bash. We're going to do rm. I don't think we need to mount in a file. And then what did it return there? think we're close. All right, no more Cedar references in there. There's one other file we have to change, which is this main.tf at the start. Alphabetized. I think that looks good. All right. Let's do a quick init. Lots of stuff is getting printed out. All right. And now here's the fun part. We have to do this. This will build everything and push it to a local registry. Let me just make sure I actually have one running. I don't. All right, let's get that up and running now. All right. Do our Terraform apply. And if I did everything right, this might actually work. I'm just going to do a double check to make sure that I got the tests set up correctly in here. Cool. All right, let's give it a try. Oh no. What do we do wrong? Could not find package Chroma. Oh, and that's because I called it PyChroma. I remember. And actually, no, that's because I haven't checked it in yet. So first, there is a way to configure this to use my local repository, but I forget how to do that. Instead, I have to actually first check that in because when this runs APKO, it's grabbing the actual packages that are built in the real Wolfie registry first. I think there is a way to do this, but I can't remember how. So instead, we will do that build ourselves one more time, see if this works, run the test ourselves manually, and then submit the package, and then move on to the next one. Not everything works the first time. Images, Chroma, configs. There we go. Something's wrong here. Cannot find Python 3. Let's copy this back over to the other directory, because I'm pretty sure we just did this, but let's fill in some more stuff here. I'm guessing it's this stuff. I'll try putting that back in here for the test. There we go. That gets injected by the command line too, but it's easy. You can be lazy and drop it here into the file. All right, let's get rid of that since we won't need it later. All right, let's do that from the documentation we wrote. The tag is a little different. So I should run it in the background on port 8000. Cool. There we go. And here's what our test will do later. Cool. So we get a heartbeat back from it. It's up and running. Now let's kill it so I don't forget. And then we could clean that up, submit a PR, and get Chroma merged, especially now that we did the scan and also see the 0 vulnerabilities. So in half an hour, we did a 0 CV build of the Chroma vector database. So we'll get that up and merged later. We have time for one more app, though, and what I was going to do next was Ollama, which is another AI tool, which kind of has this nice Docker-like CLI for building, pushing, pulling, and running models. This one's written in Go, so it's a little bit different. They have official builds for Mac that you can download, but they don't have any for Linux yet. We're working on a bunch of cool ways to get GPU stuff configured inside of Wolfie, so I figured we'd try this one too. You can see if there's a Docker file here. They just do a nice Go build. Get the binary, set up some group stuff, and then run serve. So this also runs as a server. Let's give that a try next. We're going to start again from the beginning. Let's go back to the Wolfie directory. Let's get a nice container going. And let's get some of those tools. It says we do need CGO, so that's why I grabbed the build-based stuff. We'll get GCC and some of our other compiler libraries for that build. All right. Git clone Ollama. I don't know how to pronounce it. Maybe Oyama. All right. We're in. They did pass some link flags to the Docker file in here, so let's try those too. We want CGO. Some static linking stuff. Let's give it a try. We're gonna fetch a bunch of dependencies. We're going to fetch a bunch of dependencies. We're going to slowly fetch a bunch of dependencies. Come on, go. Cool, we see some C compiler stuff. We see some warnings. See if that worked or not. Cool, exit code 0. Did work, nice. And there we have it. It built. Help. List, no models. Oh, we have to start it first. So it's both a server and a client. Cool. So nothing. We don't actually have any models. Let's try that pull. I think that was what they had next. Oh, well, let's pick a different one, the smallest one, because that's a bigger model. Let's see what happens. It says it's going to take a couple minutes. Let's let it run and just see. I have no idea what's going to happen. But while that runs and downloads, let's try to build. Stick this into Melange as well. Let's find a Go app. One that we do Go build for. We do a lot of those. All right, this looks pretty close. Start here. Good old copy paste. This is 0.0.16 with a V. It is MIT licensed. In the description, get up and running with Llama 2 and other large models locally. Build base, Go. I don't think we need bash. Let's grab here. So we've got the V. Let's get the right commit. Let's just click that, grab it from up here. Oh, we don't need all this stuff. Sometimes there are other flags, but they don't seem to pass any. Grab the Docker file. And let's drop this into spin. We should be ready to go. Let's see if the finish downloading. 72%. We're close. I don't have any of the CUDA stuff installed, so I don't even actually know what will happen if we do try to run this. Maybe it'll just run super, super slow on my CPU. But assuming this works, this should be ready to go. The Go stuff is always the easiest. Let's try doing the build while we wait. Let's do... I was just building a Zig earlier. Downloading a bunch there too. Let's see, 99%. We got it. Oh, a couple other downloads. There we go. We pulled it. It says we're running it. What happens? I just type hi. Whoa, it worked. That's awesome for running inside of Docker on my Mac without any real acceleration. That was awesome. While those Go dependencies are downloading again, I think that is probably the first LLM running inside of Wolfie in the history of the world. So everyone here was here for it. Let's see what it says to that while we wait. Same thing, just wants to know how it can assist us today. Cool, all right, so this provides the Ollama tool, some size stuff, and should be ready to go. Let's try sticking this into image. Let's try it again. Load this up into Docker. Awesome, it's up and running inside of Wolfie. Let's do a gripe scan. Zero CVEs again, nice. So that's 2 0 CVE images. Because that one's a little bit simpler, let's get that one actually sent up in a PR. That's just our linter. Open this up. Oh no, I screwed up Git. What branch am I on? This is my worst nightmare, having to fix Git while live streaming. How do I have 2 commits there? Using git sign. I have 2 commits somehow on this branch. Alright, this one I thought I already sent up where I fixed buck 2. Somehow I ended up with that one on the wrong branch. Do some Git surgery. There we go. We recovered. Let's fill out the checklist. There's no pre-existing request for this because I just thought of it, so we can remove that. There's no security fixes, not a version bump. Ready to go. All right, so CI is going to run. Then it should be good. Let's see if any lint checks fail quickly. Cool. For the Chroma one, let's name that. Let's just name that Chroma because it's an application. We don't really care that it's called PyChroma or that it's in Python. Let's just double check that file to make sure that that's there. Cool. Yep, so that's there in the user share Chroma directory. Let's get that one created too. Format it. Oh, lint passed, the update check passed, and it's building. So we just got ARM runners set up to run pre-submit. So these are using the GitHub Actions self-hosted runner. Before that only ran after commit for us. So this is a big improvement because we get a bunch of builds that failed on certain architectures later, and we had to merge them before we would notice that. So both of these are running. Cool. Let's get this pushed up. Same thing. It's under the correct license. It's still maintained. Awesome. Go. Hey, Chroma. Ollama worked. It passed. And this one's running now. Once these go in, then they get built in our CI system and they get made available. So they automatically get published to the APK index. So if you open up a Wolfie container, you can do APK add and install them using normal package manager. So this one's ready to go. Wonder if anybody's going to review it for us. I'll click merge when ready. So that'll go in. Oh no, this one failed. All right, the update check. So this check is what powers our automatic update system for packages. So it uses the GitHub GraphQL API to check the repository and see if there are any new versions available. And so depending on how projects tag things, then stuff can get a little bit hard. Yeah, see, so they have a tag in here called latest, and we can't automatically compare that. So let's see we have a couple different ways around this, but let's see what else they call their tags before we go on. So I have 047. Yeah, latest 046. Okay. So what we can do here is use tag filter. We'll do that. So it'll only look for things that start with 0. Let's give that a try. So this will tell it to ignore that latest tag. Oh wait, no, that goes the other. Yeah, okay, that does go that way. Sometimes you can do a V, except they don't use that V prefix here. That makes it a little bit hard. But it did build, so everything passed there except for the update check. It's awesome. I can't believe we got the LLM to run inside of Wolfie. I didn't actually think that would work. Still failing. What did I screw up? Did I add Chroma? I thought it was Chroma. Ah, the name here is wrong. I moved it. I forgot to fix it. One last try. I'm glad something broke. Otherwise, this session would have looked too easy and like it was too rehearsed. Come on, update check. Watching CI logs makes them go 10 times faster and pass every time, I found. Almost there. It worked. Yay. All right, so we built these two applications. As soon as they get merged, we can actually test them over in the images repository and make sure our integration tests at the end work. So the apps can come up and run. We have to come up with a cool one for the Ollama application. That was awesome. Let's click merge when ready. See if anybody reviewed my other one for us yet. No code review yet. All right, well, this should be up within the next hour, assuming somebody reviews it and it gets in and gets through the build system. So thanks for watching me write some cool packages and play around with some generative AI stuff like the vector database and the awesome, useful Ollama tool. I'm going to stop screen sharing now. And thanks again. We'll keep doing these. Send in requests if you have apps that you want me to try to build for next time. Thanks everybody for joining today.